Our goal, our new task. So the factoring quiz is now behind us. I mean, I realize that some of you are still kind of swimming in that water, but as far as I'm concerned, like we're moving on. So um, the the next task is to work with specifically, it's actually what Unit 1 is supposed to be called. We just, Mr. Walter over in Pine and myself, we called an audible like early last year and decided that Unit 1 should be preceded by a unit on factoring. So this officially marks the formal beginning of what the curriculum says is Unit 1. And what we're going to be working with for the next few weeks probably is polynomial functions. We go into some depth at this point. Like in Algebra 1, we really don't touch polynomial functions. In Algebra 2, we go moderately deep. And then if you wanted a deeper look, you can take harder classes after this, or you can wait. They offer entire courses in college that just study polynomials. But we'll give you a good look at it here and get you the idea, the basics of how to graph, how to sketch a graph, how to understand a graph, how to find the zeros of a graph. How to describe intervals of increase, intervals of decrease, intervals of positivity, negativity, pretty basic things that at first seem difficult, and they're not, provided that the basics are intact. And you won't see any hard factoring for a little while. The factoring today, for example, that you'll see in my 4 examples is just quadratics at worst. So the point of today isn't really to talk about factoring as much as it is just to introduce ourselves to what a polynomial function looks like. And my goal for you is to, when you leave this room, to be able to look at a function and describe its end behavior, to be able to find its zeros, and we'll talk about that, to be able to make a sketch of it, and to be able to describe the intervals where the polynomial is either positive or negative. Chromebook away, please. I don't want to have to keep saying that. I hate those things. I just hate them. They're becoming almost as bad as phones. So thanks. Good. So let's get to it. The first thing is end behavior. And so I'll just go to Desmos real quick and just show you an example of a polynomial function, just so you can see what it looks like if this thing would quit getting in my way. So if I typed in like x to the third minus 4x squared plus 2x minus 5. This is an example of what a polynomial function can look like. This particular polynomial function is what we call a cubic, right? It has a third degree. You watched me type it in. X to the third means third degree. So that means it's going to have this particular shape. It's going to kind of have an up, a bend down, and then a bend back up. Now, I want you to see what happens. By the way, that's like, we're not going to go into huge detail about all the like specific highs and lows. That's more of a calculus-y kind of thing. But if I put a negative in the front, would anyone like to guess what happens to the graph if I put a negative? What do you mean? No. What do you mean by it flips? Something flips for sure. Kind of, but not. It doesn't. I see what you're saying, and it's not actually a horizontal reflection, but it will kind of almost look like it. And so that's good thinking. Watch what happens when I add this negative at the front. So look at that graph and then, whoop. What did it do? Let me take the negative off again and let's look at that graph. Do you see how it starts low, comes up, and it ends high? And say that again. It starts low, right? And it ends high. That's called end behavior. When we talk about the end behavior of a polynomial graph, we're studying what does it do as x goes forever to the left, and what does it do as x goes forever to the right. So if I were to have you describe the end behavior of this function, there's a much more complex way to do it. I learned years ago to knock it off with that garbage. We're going to call this low high. What that means is the end behavior is low on the left, high on the right. And don't worry, I'll give you a lot of good stuff to put in your notes once I'm done with this awkward introduction, okay? Now, when I add a negative to the front, what would you describe it as now? high, low, right? It starts high, comes in from the north, and then it ends low. And that's all because I put a negative on the front. Watch what happens if I change the degree from a 3 to a 4. What would you say is the end behavior of this polynomial function? Low, low. Very good. And then watch what happens if I take the negative off. You want to guess what it's going to be? It's going to be high, high. Do you see it? Look at the cool behavior of that graph. It's so neat how they just do their thing right there. There's so much intricate math happening in between in the trenches there. But what we're interested in today mostly is end behavior. And I'll show you exactly how to look at a function from its written form and be able to identify. And your answer for end behavior will always be one of 4 things: low, high, high, low, high, high, or low, low. Like the graph can't do anything other than those 4 things. I hope you agree. So having said that, let's go back to the other board now, and I'll just write a function up here. And by the way, get used to this notation. We're not going to write y equals. We're going to start training ourselves to use proper function notation. It, pardon the pun, functions the same as y equals, but we want to really train ourselves to think of f of x, f of t, stuff like that. So the function f of x, let me give you 5x to the third minus 18x squared minus 8x. I said nothing that would directly indicate the answer to this. I just wonder if anyone was picking it up kind of passively as I spoke. Would anyone like to take a shot from this at what the end behavior is without ever seeing the graph?
It's a normal square. Low to high.
It's low, high. So here's the deal, and I'm going to show you how to study this, just like I tried to do with factoring. Like there's a sequential way to think about things. The first thing you want to look at is the degree. And we all agree that that degree is odd. That's important. If the degree of the function is odd, then the end behaviors will be different. If it's odd, do you see how 3 is an odd number? The degree is the highest exponent, right? Good. So if it's a 3 or a 1 or a 5 or a 7 or a 9, if it's any odd number, then you know that your end behavior is either low, high, or high, low. They're going to be different end behaviors. The graph's either going to start low and end high or start high and end low. Look at the number in the front. You agree that that's a positive? When the yellow number is odd and the red number is positive, then your end behavior is low, high. And you'll see why this is so ungodly important here if I can get through this today. Let's do another example. Which number do we look at first? Starts with a D. The degree. Good. Get used to saying that word. The degree of this polynomial is the yellow number 3. What is 3? What does that tell us? The end behaviors will not be the same. Very good. So we're either dealing with a low to high or a high to low. The number in front is negative. What do you suppose that tells us? Yes, it certainly is. Good job. So this graph is going to begin high and do its thing. It's going to do its little boobity boobity boo. And then at the end, when it says Elvis has left the building and it heads forever to the right, it will end up going forever to the low. So far, so kind of good. Okay. I'm going to leave the screen like that, but I do need to write down the next example. So our third function is f of x equals 3x squared plus 8x plus 5. If I'm any good at this, you've picked up what I've said. Which number do we look at first? The degree. And the degree is what number up there on the board? The 2, right. And what is this degree? Even. What does even degree, you suppose, tell us about the end behavior? They're going to be samesies. They're either going to be up, up, so both arms of the graph are going to go up, or both arms of the graph are going to go down. What do you think this positive number in the front tells us? It's high, high. And you can say up, up, you can say up instead of high, you can say down instead of low, whatever kind of thing makes more clicky sense with you. So to be consistent with what I've already put, I'm going to put high, high. Some people call it up, up. Okay. And of course, you know where this is headed. The last example has got to logically be, what do you know I'm about to write? A negative number and something even. Good. You got it. Not odd, but negative for the leading coefficient and even for the degree. So the fact that the degree is even tells us what?
Oh,
It doesn't tell us. It just tells us that they're going to be the same. They're either both going down or they're both going up, right? It's like factoring. One number often isn't enough to tell us what we need. The two only tells us that the ends, the arms are going to behave similarly. And then we default, we look or defer to the -5. And what does he tell us? Because he's negative, that they're both going to be low. So they're going to go low, low. So what that does is it opens up one part of graphing for us. The other part of the puzzle today, if I can, and again, time might be an issue. I think I'm down to like 7 minutes. So I'll do my best and we can pick it up on Monday if I get cut off. But I'm not going to race through it just to beat the clock. So far, all I want you to get out of this is to be able to look at a polynomial, a function f of x equals blah, 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 and be able to say end behavior is low, high, low, high, or low, low. That's mission one. Now, you might ask yourself something like, well, why does that do us any good? Well, here's why. Because our ultimate goal here for this side of things is to make a graph by hand. And so I'm going to go back to the first example that I gave you. You already have this one written down. I'm just going to write it down again because it deserves some more space now. There. So what did we decide was the end behavior of this polynomial function? Low to high. So if you gave me a set of axes and told me to graph it, at this point, I don't know much. This becomes your thing. It's like, okay, can I make a graph? Well, here's what I know. When it comes in from this left direction, it comes in from the south. And when it comes in from the right direction, it comes in or exits to the north. I don't want to move on until you agree with that. All I've illustrated here is the end behavior of the graph. We agree? So what we're going to study now is how can I get a little bit more information about what's happening in between the lines? So there's some stuff, there's some little song and dance happening inside the ropes. And what we're going to do is use our mad algebra factoring skills to figure out some key pieces of information. And they are called the zeros. So get used to this word. You're going to need to start finding the zeros. And zeros is a fancy term for places where the graph crosses the x-axis. Think about this for a second. Like, and I'm just going to make this up, just so don't write what I'm about to write. But if someone walked in here right now, said, oh, by the way, the graph crosses the x-axis right here and right here and right here. Again, I'm making that up completely. But if someone told me that that was true, then I'd say, okay, thank you. I can now complete my graph. I can cross there, I can cross there, and I can cross there. I just made you a graph. That's where finding those zeros becomes the kind of the missing piece, if you will. So we're going to use some simple algebra to find the zeros ourselves. So let me erase this because it's not true. Those 3 yellow dots are probably not even close to correct. So here we go. For a moment now, we're not going to talk about graphs. We're going to talk about basic algebra. We're going to use the F word. What's that F word? Factoring. We're going to take this polynomial and we're going to factor it. When you factor a polynomial, why that is so beneficial is because if you think about it, if you set that polynomial equal to 0, then you are forcing the hand, you're forcing the math gods to tell you where the y value is 0. And if the y value is 0, then I'm on the x-axis. If that was confusing, it won't be after you practice. It'll just start clicking and clicking. So let's focus on the right-hand side over there. If I put this on yesterday's quiz and I said, factor, what's the first thing you would do? Bless your heart. I would pull out a GCF. And what is the GCF? It is x. And then I'm going to rebuild what's left over, which is 5x something, 1x something. And I need to make an 8. And just to save us all the time, I can tell you for sure there's got to be a 4 and a 2 placed like that. Take a look at it, you'll agree, because you're going to get a 20 and a 2, and 20 and 2 make 18, right? When one of them's a negative. So the minus is obviously going to go on the 20 like that, and the plus is obviously going to go on the 2. And for the first time ever, we actually really get to use factoring for something other than just factoring. Like factoring to this point has just been something we did because that stupid guy with the lanyard in the front of the room made me learn how to do it. But now we actually use it for a purpose. Now we can actually say, okay, there are 3 factors on the board. One of them is red. And to make the red factor equal 0, x has to equal 0. To make the yellow factor equal 0, x has to equal -2/5. And to make the purple factor equal 0, x has to equal 4. You've done this before. It's just been a minute. The red one obviously is 0 because the only thing you could put in place of red guy is 0, right? And then the yellow one, I just took the opposite and then I divided 2 by 5. So what I just found, those red, yellow, and purple numbers are the places that are going to complete the puzzle. So I'm going to head back up to my graph now, and I'm going to make marks on my x-axis, and I will color code them for your educational convenience. I'm going to start by making a mark at 0, and I'm just going to estimate where I think -2/5 might be, something like this. And then I'm going to estimate where I think 4 might be, maybe something like this. And what you now see is that these arms that I've drawn earlier, they're a little out of place, aren't they? They were really just there for visual effect. So what we're going to do is we're going to now understand the nature of the graph. We see the way it has to behave. Without end behavior, I wouldn't know, does the graph go like this? Right? Or does it go the other way? And that's where end behavior playing together with the zeros, they form that perfect union and they tell us exactly what the graph looks like. So we know the graph ends down here like this. We know the graph ends up here like this, and that should be enough to get us our graph. So here we go. We're going to make a sketch. We're going to come up through this 0. We're going to double back down, try to make it look decent through this other 0. We're going to probably dive deeper since these are further apart. And then we're going to double back up and come up through this last 0. And that is how you sketch the graph of a polynomial function. You can see in this case that neither one is any more important than the other. You can't do it without the zeros, and you can't do it without the end behavior, right? All right, so I'm going to cut myself off because I'm out of time. We'll resume this on Monday. Okay, remember, don't forget, get in here today, find the time, get your quiz done.